We're going to be discussing digestion, specifically what enzymes take place in chemical digestion. Now, digestion is going to begin in the oral cavity, specifically through the process of mechanical digestion, which is going to be done with your teeth, physically in the mouth, in the oral cavity. Then chemical digestion is going to take place with the salivary glands secreting salivary amylase, which is used to break down starch, a polysaccharide, into maltose and small oligosaccharides. Once that process of mechanical and chemical digestion create, a bolus will be formed in the mouth with the food, with a mixture of salivas where we swallow down the throat through the esophagus to then reach the stomach. Here the food is going to encounter a very acidic environment. This is around a pH of 2, which is going to denature proteins and enhance enzymatic access. So in this region, what we're going to experience is pepsinogen, which is secreted by chief cells, is going to be activated into pepsin by hydrochloric acid. And the pepsin cleaves peptide bonds, primarily targeting proteins, producing shorter polypeptides. After that occurs, through peristalsis, the bolus becomes a chyme as it makes its way through the small intestines, which is going to be the layers of the duodenum, the jejunum, and the ileum. And here's where most enzymatic processes occur, right? So here specifically, we will have secretions from the pancreas as well as the liver that will secrete enzymes into the small intestines, so that we can further absorb and break down the foods that we have consumed. They're going to focus on the digestion of carbohydrates, proteins, and lipids. First, we're going to focus on what the pancreas secretes. So the pancreas is going to secrete pancreatic amylase, which is going to continue starch breaking down into disaccharides. And then we have pancreatic lipase, which is going to help with the breakdown of specific lipids into free fatty acids and monoglycerides, and as well as trypsin and chymotrypsin, which is activated by zymogens by enterokinase on the intestinal brush border, which further break apart the polypeptides into even smaller peptides in the small intestine. As this all is occurring, the liver is going to be creating bile, and the gallbladder will be storing, maturing, and fermenting the bile so that it can help the process further along. But the bile itself does not necessarily contain any enzymes, specifically no digestive enzymes. So here's a nice image of the brush border right over here, where these are the final stages of enzymatic and specifically more chemical digestion occur. And what is going to happen here is the completion of hydrolysis of disaccharides and peptides. So maltase cleaves maltose into 2 molecules of glucose, sucrase cleaves sucrose into glucose and fructose, lactase hydrolyzes lactose into glucose and galactose, and peptidases further break down into individual amino acids. And then that's when absorbable monomers, for instance, amino acids, free fatty acids, and monoglycerides are going to be transported across enterocytes lining the small intestine, which is what we're looking at here. So the monosaccharides and the amino acids are going to enter the capillaries, as you can see right over here, through secondary and active transport as well as facilitated diffusion. So lipids are going to be more so absorbed through the lacteals, and they form micelles for absorption and reassemble into chylomicrons, which are transported into the lacteals of the lymphatic system. And that is the process of chemical digestion with most enzymes and what they do in this part of the body.